Welcome to the Trend Detection Podcast, powered by Siemens. And now your host, Niall Sullivan.
So welcome everyone today. So my name's Niall Sullivan. I'm the VP of Marketing at Senseye. This is the second sort of live session we've ran, so it's sort of a live interactive session. And as I was sort of saying before to a few who joined, we're actually recording this for our podcast, the Trend Detection Podcast. So that'll be published hopefully later this week and on our YouTube channel as well. So you'll be able to sort of watch it back and share with colleagues if you want to. I just wanted to quickly go through the format. It's all very straightforward, really. So as you can see, I've got Alex here as well, who I'll ask to introduce himself in just a second. But so essentially it'll be a live Q&A. So I'm going to be interviewing Alex. But what I'd really like is your participation too as well. So if you have any questions at any point, if you just pop them in the chat, what I'll do is I'll invite you to come on and ask Alex directly live. If you don't want to do that, that's absolutely fine. I could read that out as well. But I think it'd be great for sort of conversation stuff to make it as interactive as possible. You can come on camera if you want as well, but I won't force anyone into that. As you can see, my camera work's not very good at the minute. But yeah, it's just more important that we have sort of really interactive session here, and it's a good opportunity to talk to Alex. So yeah, without further ado, I'll ask Alex to introduce himself.
Thank you, Niall. I'm Alexander Hill, one of the co-founders of Senseye, and based in Nashville, Tennessee. Not that my accent betrays that at all. So I've been in Nashville now for about 3 years, and I moved over here to support our business in North America and grow it in this region. And I work primarily on our global strategy, so working on our messaging and also helping our partners, and that's an area that we're focusing on more and more. We started Senseye back in 2014, 2015, and it's been quite a wild ride since then. So I'd love to help with any of your very difficult questions. That'd be fantastic. Just give a little bit of idea about my background. I was originally a digital systems engineer. So I did my engineering degree back in Southampton University in the UK. And then I worked in software and aerospace and defense for a few years, and then betrayed my engineering heritage and went into sales and marketing. So I took the easy route, and now that's my main focus. So I do have an engineering background. It's been a long time since I wrote any code or did any proper work in anger. And I have to say I miss it sometimes, but it gives me a technical appreciation for what we're doing and the difficulty of what we're doing. It's a long time since any of my code hit the Senseye application there, in case you're starting to get worried about that.
Oh, great. No, thanks for that. So we it's interesting. Alex asked for difficult questions. I think we all heard that. It's been recorded now, so feel free to to give them a grilling, I guess, is what we're trying to encourage here. And also,
it's a lot more fun.
Yeah, exactly. We want to be challenged here at Senseye, so let's go for it. So today we're actually talking. So the topic today is actually about building a business case for predictive maintenance. And I've worked lots of different sort of SaaS businesses before, but I've never seen it firsthand just how sort of collaborative that process is between the vendor and the customer or prospect. So I think it's a really interesting area, because we really do sort of work alongside potential customers in helping with that. So I guess the most natural place to start would be, what are the key points that need to be covered as part of a predictive maintenance business case, Alex? Your opinion?
It's interesting when you mentioned that collaborative element. And I think part of that is, it's any real serious enterprise or at scale deployment is going to need a collaborative element. You can't, with each business being unique, you've got to treat them uniquely. And predictive maintenance is particularly one of these areas where, for quite a while, it's been on the fringes of technology and innovation. It's been one of these things that's been described as it's coming soon, and it's going to have all these fantastic applications and benefits. And it's here now. But it's taken a lot of effort to get it there. And particularly in the last couple of years, we've noticed that our conversations are less and less about teaching people what predictive maintenance is, rather teaching them how to benefit from it correctly. And so people often think, what technology, what sensors and things do I need to install? And it's not about that. It's not about go and spend hundreds of thousands of dollars on sensors, because actually any equipment in the last 10, 15, maybe even 20 years probably collects the kind of data that you already want, at a very basic level. And often that's enough. That's enough to get started, and it's essentially free. So the conversation needs to come into more of, what machines do you have, and what's your capability of getting the data out of that? What's your capability to extract that data and stick it somewhere where we can get it, or is it something that you need us to be doing? And so there needs to be a discussion, a very, very open discussion about what are the capabilities here, and how can we just make this happen? And I want to steer away from the technology, because I feel like actually the technology, at least from our point of view, it's proven. We have deployments that are tens of thousands of machines with hundreds of users at the same time all across the world. And the technology is there. It's proven, it's fine. We've developed it from the ground up. The real issue actually is cultural in businesses. It's getting people to believe in it. And that's harder work than it really should be. You show them these fantastic case studies, you put them in touch with customers, you sit them down in the same room, and you can have one customer who's mature talking about the wins that they've had, and you still get a lot of skepticism. And I think that's going to be natural for anything that is relatively new. But it reminds me of people in the 90s talking about how the internet's just a fad, and we're not sure if there's a business case for it, and it can get a little bit frustrating sometimes. So we've invested a lot in the tools and processes and knowledge and templates that we can put into customers' hands and say, look, this is the material that we have, that we use to educate people. You can use this internally as well, and we're going to make this all available to you. We make it available to our partners, and we try to make it as simple as possible. So, these are the processes that we use, and now you can use that and adopt it and change it if you need for your business. And of course, we'll hold people's hands doing that. But we found it's much better to be open about the information rather than trying to keep it secret, or saying you need to go and talk to a really expensive consultancy who's going to make this custom plan for you. We'll just give it to you, and that's a lot of our work, is trying to make sure that culturally businesses are ready to adopt this technology and benefit from it. Because the most important thing actually, it's not how many sensors do you have and what do they collect. It's what's the business case? What KPIs are you going to affect by doing this? Or is this a science project? If it's a science project, then you're too late for that. It's been done already many years ago by a few other companies. This is not the time to be running a science project in this area. There are other things you can be experimenting with. This is now, I'm not going to call it a mature market, a mature area, but it's one that is rapidly heading that way. So you need to have a very good understanding, and we can help with that, but you need to have a very good understanding of the top level KPIs you want to be affecting. Everyone always focuses immediately on downtime avoidance or availability, and that's very good. It's nice. I've gone on some private rants about that, and not private, public rants about how downtime avoidance is cost avoidance. It's not cost savings. And so the problem you have in justifying a project on downtime avoidance is at some point, somebody with an accountancy degree is going to come up to you and say, hey, about this $10 million you say you've saved, I'd like to spend it somewhere else, please. And you can't, because it's cost avoidance. It's not an actual cost saving. So the more mature KPIs are then things like efficiency or reduced maintenance spend, reduced operations spend. Those take longer to show, and you need to be prepared for that. I think it's always good to start on downtime avoidance immediately as a good KPI, but then be prepared to evolve that messaging internally. How else are you going to describe the wins from this project to your colleagues and to people who might not know it so much and might come at it with a more skeptical viewpoint? And kind of on that note, how are you going to show the benefit to your colleagues is, how are you going to integrate this? How are you going to make sure that it's scalable across your business and it integrates into other areas of your business? So predictive maintenance as a methodology is not something that runs in isolation. You are directly tied into the operational side of things, to the quality side of things, to absolutely everything. And then you can get more sophisticated and tie it back into your actual original engineering for the product and see how that behaves in the machines, and just have this full communication with your customers as well. So what directions do you want to take your integration in? Usually we say start with your maintenance management system. or your enterprise asset management system, because that gives you that direct automated tie-in for, okay, my machine's doing this. Now I need to raise a work order and do that automatically, and then have Senseye or some predictive maintenance tool learn automatically from that. You want to be closing that loop so that you've got this full intelligent system, always looking at your machines, always ready to watch for something happening and automate when a human needs to come and take a look and intervene and then learn from that. So the integration is really, really important. This kind of system can work in isolation, but it's not the recommended way to do things. You don't want to be creating another silo. You want to be joining these things up so that you can get the most benefit from it. And that's when you see the real efficiency wins. And then further to that point is you need someone to own it. Who's going to own it and who's going to drive it? And those might be different people. Typically, when we started, we always believed, okay, it's the maintainers, it's the maintenance team, the operational technology people, or more on that side of things, who will own it and run it. But more and more, we've been seeing that IT owns it. It's ultimately an IT application. We can't get away from that. It's cloud-based, but it ends up being an IT application with maintenance often owning it, or often running it even. And in order to get the best success within an organization, you really need to have an overall team that are coordinating the deployment of this kind of technology. Think of it as you can leave it to the individual plants, but really you should have an overall architecture that you can create and show to the plant and say, this is the exemplar way to do this, and now we'll help and guide you. And that's always better coming internally with some external help from us, rather than us trying to say, this is how you should do it all the time, because you need to have that internal buy-in. So it's my very long-winded reply on what are the key points that need to be covered in PDM business case. So in summary, that's machines. Are they ready? Can you actually get data from them? Are they suitable? And when I say, are they suitable, many people think, oh, it's only rotating machinery. For many companies, that's true. For us, it's not. We can take any kind of machinery. So most of our machinery is non-rotating. I'd say only 20%, 30% of our machinery that we cover is classified as rotating machinery. Is your data ready? Do you have something stored, or do you have the ability to pull it out, stick it in a historian somewhere? What's your culture like? Are people going to fight this, or are they going to be bought in? And can you share that learning? Are there ways to share successes and get people excited internally? What's the business case? What are your KPIs that you're going to be affecting, and how? What do you call success? How is it going to integrate? How is it going to scale? What tools you want it to integrate with? And who's going to use it? Who's going to own it?
Fantastic. No, there's a lot of good information there, and a lot to dig into as well. I mean, the first point, and sort of the key words, it's a key word here a lot. The Senseye is around culture, and how culture is such an important part of sort of the journey our customers go on. But what I wanted to sort of ask first of all is, from your experience, Alex, does it vary via industry? How, whether one industry is more culturally ready than the other, or is it not as simple as that?
I think if you asked me this 2 years ago, it would have been a simple answer. And the pandemic has changed things. Silicon shortage has changed things. And you have different drivers for different things. So for a while, most of our business was done in the automotive industry. And we had this feeling that they were more culturally ready because there's a lot of just-in-time production. There's a lot of wrangling supply chains, and downtime is absolutely critical. And particularly in automotive now, we're seeing that downtime is less important because they're having a lot of downtime anyway. They can't get the chips to produce cars, so those machines are down. So how do they justify predictive maintenance when you can't actually do it by downtime avoided? And the answer is, well, you look into things like labor cost reduction, asset lifetime extension, and overtime reduction. So if you're having to pull people on at weekends to do extra maintenance work and things, then actually don't do that. Just schedule it in where you're going to have some downtime. Use your predictive maintenance tool to do that. So automotive is an interesting case where they've actually gone from high dependency on downtime to now it's almost not something that we talk about really. And I would have said similar for food and beverage, or fast-moving consumer goods. There was a lot of, they weren't particularly focused on downtime. there's a lot of parallelism, a lot of feelings that actually, well, if this line goes down, we can just produce this product on this other line. And what's most important is quality. What's most important is making sure that we can actually hit this production run when we need to, and making sure that that's sustainable. And I think that suddenly downtime has become more important to them, because now all of these factories, people working from home, there's been a huge surge in consumer goods and demand for that. And suddenly these factories that were operating in a fairly, I don't want to say lazy manner at all, but in a more, in a less downtime critical manner, are now finding that downtime is more and more painful. And so they've actually gone something of the opposite way. There are cases though where, and this is a caveat, there's going to be a caveat to everything I say. There are issues where people say that actually, we don't have a problem with downtime. What we do have is a problem of spending too much on maintenance. It comes down to that argument of over maintenance is always cheaper than failure. That's true. It's just really expensive. So if you can reduce the amount that you spend on maintenance, or look at multiple sites that are potentially producing the same or similar product and say, okay, why is this plant costing me 2 times in maintenance what this other one is? Then you can start to compare apples to apples and find ways to optimize and reduce that cost. The other sector that we focus on more and more now is mining and metals. And I'd say that actually they've always been culturally ready for this kind of technology. They've always had a very similar outlook, as very similar to oil and gas, where they've got a lot of data historians, they have a lot of remote assets. They've understood that actually collecting this data right now, even though they might not have a way to process it until 5 or 10 years' time, collecting the data now and investing in that technology to do that is really worthwhile. And we've seen that more and more, where particularly our mining and metals customers, we come along and say, hey, do you have any data? And they say, yeah, how many years do you want? And that's really nice and refreshing compared to some other industries. So I do think that mining and metals is probably ahead of the curve, but these other industries are catching up very, very quickly.
I was also going to sort of hone in, because we've mentioned sort of downtime, but you touched on a few other, overspending on maintenance and overtime. So it's just some of those, and you mentioned in the first answer about not relying too much on downtime as like a key central part of your sort of business case. So can we sort of dive into some of the other areas you'd recommend people focus on as well, or look within their organization for?
Yeah, I think to take that question back, it depends on who you're talking to, and different people are going to have different things they care about. So often the maintainers on the front line, they will have downtime related KPIs that are their job performance KPIs. So it could be a number of major breakdowns you've had, or all of these things. And so they're incentivized to keep downtime down or keep major breakdowns down. Then as you get more to a manager level, you have more, I don't say softer, but higher level KPIs that often take longer to measure. So throughput, safety, how connected your mobile workforce is, how supported they are, how able they are to do their job remotely now, which is more and more important. You get into areas like asset lifetime extension. Okay, you've bought these machines for however many $1 million, and you expect to get them lasting for 5 years. Can you get them going for 7 or 10 years? Because that's a direct capital saving and directly benefits your budget. And then you get to senior managers and above, so VP level directors and so on, C levels, who are starting to care more and more about organizational efficiency and sustainability. And when I talk about sustainability, and this is a word that I don't want to say we're sick of, but I think everyone is hearing this word more and more and more from every organization. And it means so many things for different people. So I want to quantify it for when we talk about sustainability. We're not just talking about energy reduction. That seems to be what a lot of companies are talking about. Okay, if you work in predictive maintenance, then it's sustainability because you'll have healthier machines that use less energy. That's correct, but it's missing some of the key points, some of the more exciting points that actually drive direct CapEx savings and turn sustainability into a cost saving a proper cost saving with money in your pocket you can go and spend somewhere else rather than a cost center. And those are fundamentally reduced spare parts usage. So you can reduce the amount of inventory that you have sitting on a shelf. That's money in your pocket, because you now have a much clearer view of what's going to be happening in the next 2 weeks to 6 months. And you can plan that accordingly. You don't have to have a massive stock of inventory sitting there. Asset lifetime extension, we talked about. Okay, you've had your spending on these machines. How can you now extend that out? And that's again it'd be a direct OpEx saving potentially. And then you've got some other areas like safety and environmental risk reduction. We're seeing that captured more and more, that actually when a large breakdown is avoided, people will report that there could have been a potential environmental contamination. And that can have all kinds of effects and everything from fines to bad PR to bad customer relations and all of these other areas that are then actually helped by having that much better view of what's going on with your machines.
Really, really interesting. I mean, it's funny you mentioned sustainability, because obviously that's they're sort of very corporate KPIs in a lot of ways. And another most strategic objective, a lot of large companies is obviously around digital transformation as well. And I know we've been talking internally about where does PDM fit into that. So it might be good to dive into that a little bit. How predictive maintenance can be positioned within that digital transformation strategy, which is so important now, and can it be leveraged as part of the business case?
I think unquestionably yes. And predictive maintenance, my firm belief is that it's the foundational element of a digital acceleration strategy. And we've seen this happen now at customer sites where they have a very new digital acceleration team, and they get their hands on predictive maintenance and they make that work. And people have seen, why do we have digital acceleration? Why do we need that? I don't understand what the benefit is. When that team then comes along with massive efficiency and reliability improvements, and they can say at the end of the year, this is how many millions of dollars we saved you, and this is how much time we saved you, then I'm thinking of one particular team now in North America. They've now had their responsibilities blossom and boom, and they're the darlings of the plant, where everyone wants them to come in and help with something. And they've gone from this team that's kind of been shunned and on the edge, and okay, well, you guys are just playing around, to now, okay, well, how can digital acceleration help me to do these other things, these other jobs that I really care about? How can it now help me to affect quality and throughput and these other things? And predictive maintenance is, without a doubt, the fantastic entry point to show a rapid ROI and the power of having your assets and your information connected.
Actually, that's another thing to focus on, is return on investment. So you said a rapid return on investment. So how do you actually measure the financial impact, of predictive maintenance within an organization, or how can you position that in the business case?
It comes down to what's the key points that need to be covered, and that is the KPI. What KPI are you going to agree on as an organization? We can come along and say, okay, if you want downtime, then we can actually guarantee the financial return of your project based on downtime avoidance. We're actually working on our ROI lock version 2, which will then be about other KPIs that are somewhat harder to measure. But downtime is a good one. And I know I bag on downtime a lot. But as long as you can accept that it's a cost avoidance rather than a cost saving, and not necessarily money in your pocket, then it's still very valid, because it's extremely quick to show results. Immediately, okay, well, if this had failed in production, it would have cost me 2 hours downtime, and that would be $500,000. Okay, well, that's a saving. That's something. Also, that's a cost avoidance. That's something you can say, like, I didn't have to spend this money. I didn't lose out on this money, and there's a very quick, attractive number that starts to build up that you can show to other people.
Yeah, actually,
when you're looking at things like efficiency and so on, it takes longer to measure, and then you need to be looking, okay, on a quarter-on-quarter basis, how did my maintenance budget reduce? How did I manage to avoid doing things like manual inspections? Did I manage to avoid doing planned maintenance that would have cost me money and was actually unnecessary? And that's one of the main points of sustainability that I forgot to mention. If you can reduce your planned maintenance and you can do it confidently, knowing that your machines are actually showing no signs of issues, and you can skip that maintenance interval, you can skip replacing these parts, you can skip potentially introducing additional failures, then that's fantastic. That's proper money saved.
Yeah, but probably say at this point, we did, Alex was trying to encourage everyone to ask some tough questions. So just as a reminder, you can feel free to put some in the chat to, we could put to him at any point, and then you can come on and ask. So just wanted to put that reminder in there just quickly. But I guess we were talking about sort of the potential for a quick return on investment. Obviously, I guess that has to have certain things in place, but in terms of the actual project, and projects can vary, I guess, depending on the complexity and the industry. But how long typically do they take? Because I guess as part of a business case, you'd need to include that sort of information in terms of that initial rollout phase. Let's break it down, I guess, into the initial sort of rollout phase, and when you're starting to see the initial return on investment and the positive signals, and then also what are the steps that you can put in place in order to get, to ensure that it does run on time and within budget as well.
Yeah. Okay. So there's a few questions in that.
Yeah.
And let me start with the phases that we define of a predictive maintenance deployment. So that's designing it, deploying it, operating it, and then refining it. And that's the acknowledgement that this never finishes. Yes, you'll have success, and you'll have your initial success, and you want year-on-year success. You want to have continued success. You don't want this to be a project where you initially get some good returns, and then then it starts to be a sunken cost. You don't want that at all. This should be something that is then critical to driving business efficiency on a continued basis, and able to show that it's always paying for itself, at least paying for itself. In our experience, projects, once they enter the operate phase, so once you have actually connected your data streams, you've got data coming in, you've got people using it, the return on investment is typically 3 to 6 months. We do have some industries that take a bit longer. Historically, fast-moving consumer goods have been slower because they often the actual value of that product is less. And so it's quite different to automotive, where they're producing one car every 60 seconds that might cost $50,000. And that's quite a significant cost if you're looking at downtime avoidance. How you can stick to doing that comes down to culture and planning again. So again, from our point of view, the technology is there, it's done. The way that we approach these projects is we don't design models from scratch. Well, we do and we don't. Senseye by itself, Senseye Predictive Maintenance, uses AI and machine learning to design and build and maintain models for each machine completely uniquely, and does that completely automatically. So we don't do it by hand. That's a cost saving and a time saving. And we've developed the technology to instead develop a completely unique model for each machine. And that sounds like the opposite way of achieving scalability. But we've actually found it's much quicker to do that rather than trying to have a generic asset and tweak that, because then you're introducing humans into the loop, and that makes it a much slower, more difficult process. So as far as possible, we want it to be as automated as possible. By far, the biggest element of these phases that we talk about in terms of time is the designing and deploying, making sure that you'll actually be able to get data as you need it, do some data wrangling, because inevitably there's going to be a little bit of fiddling and tweaking of the way the data comes in, or where it's stored, or how it's sent, or even just discussing with IT people about which ports need to be opened in order to send that data. But there's always going to be some discussion around that, and that's bringing in lots of different people with lots of different concerns, and they all need to be worked with. What we do to try to help getting to that return on investment, getting to people seeing that as soon as possible, is a couple of things. Our technology is designed to be scalable. And so we promote customers starting with more machines than they typically think. We have a lot of people coming to us saying, okay, I've got these 5 machines. These are really interesting. How can I run a predictive maintenance project on these? And we'll come back and say, actually, what about these 500 machines you've got around them? And that's not because we're greedy. It's because the more machines that you cover to start with, the higher chance you have of seeing something interesting. The worst projects that we have, and this is in our past, and we don't really do this anymore, the worst ones we've had are where people come along and say, I've got these 3 machines in my innovation center. We'd like you to monitor them, please. And we monitor them. And everyone says, yes, that's very interesting. It's being monitored. And then nothing happens because those machines don't fail. They're the darlings. They're the ones that people are always tweaking, they're always looking at. And we come to the end of the project and people say, well, that was very interesting, but we didn't see a business case. And we respond by saying, okay, well, because you had 3 machines. Of course, there's going to be no business case. The more machines you have, the higher chance there is of actually seeing that ROI much, much sooner. And you'll also start to see things that you never would have expected. I can't tell you how many examples we have of machines that people brought in just because the data was available. And actually it turned out that was a really highly critical issue. And if that had failed, that would have cost millions and millions of dollars. Actually, a good example of that is a transformer we recently saw on a production line. It's not even a moving machine. But we started bringing in the data for that. We started to see some very unusual behavior. And it ended up needing replacement. But if that had continued, that would have actually burned out all the motors and drives on that line. And that would have been millions of dollars in actual equipment replacement costs, as well as unplanned downtime. So these things, my summary in that is bring in more machines than you're initially thinking, because you have a much higher chance of success, a much higher chance to achieve your budget and the desired ROI. And appreciate that, and make sure the culture is there, make sure there's a team buying into it on your side. We will do everything that we can to help and to push your success and to highlight your success and to show that within your organization. But you also, we can't be fighting against the tide. We need somebody who's also doing that within the organization, who understands how to navigate it, because each organization is unique. Short answer, 3 to 6 months. Long answer, rewind and listen to that.
Oh, awesome. No, brilliant answer. Thank you. We've actually got a question from Mike, and I'm going to ask you to unmute and ask Alex directly if you're happy to do that. That'd be really great.
You put him on the spot now.
I know. I'm happy to read out the question as well if you just put in the chat if you don't want to. It's fine. I'll read it out. It's so are there reliable statements about how the availability of technology such as predictive maintenance for machine builders influences the purchasing behavior of customers? Return on investment through more plants sold?
So this is an interesting one, focusing more on the OEM than a producer, I suppose. So let me take it from the angle that I think it's going at, and please correct me if I'm wrong. If you're producing machines to be used by your customers in the field, and you want to transform your business to be an equipment as a service angle, so you're not just selling the machine and the maintenance package, you're now selling the capability of that machine as a service, as a subscription service, then predictive maintenance becomes essential to delivering that. There's no way that you can put machines in the field or in remote sites. Well, there is. It's just very expensive. It's very, very expensive to put machines in the field or customer sites without having some form of remote monitoring predictive maintenance capability. So you could either tackle that by having lots of people and lots of vans go around and check things, or you can monitor it remotely and understand in a more efficient manner where those people and vans need to be ahead of time before your customer's on the phone shouting at you that the machine that they're paying for or the capability that they're paying for isn't working. And we're seeing that happen more and more, where companies are starting to explore things like movement as a service, tons per hour or welds per hour, those kinds of things. A lot of companies are already working in an area like Tetra Pak, where they will give you the machine and you'll say, okay, I want to be packaging 3,000 cartons of orange juice per hour. And you'll actually be buying the cartons. That's what they care about, and the capability of that, rather than the machine itself. I was debating internally whether I talk about aerospace or not, because this is something that's happened in aerospace for a long time. I just feel like we sound like a broken record talking about aerospace. Everyone does. But the fact is that they are decades ahead of other industries in using predictive maintenance and condition monitoring to drive new business models. And you can have aircraft as a service, you can have warfare as a service now, driven through condition monitoring and predictive maintenance.
Yeah, there's a lot of developments in that area still. So we've got another question from David, and yeah. Oh, you're ahead of me. You can unmute yourself.
Yeah. So my question is, I work in the appliance industry. Equipment's going to fail. We have call centers that manage the inflow of a bunch of data, failure types, that sort of thing that are coming from our customers. Their KPIs are counter to the KPIs of the service team, who is, I need to get out there and spend as little time as possible going to job sites where there's no real value in me sending a $150 an hour technician out to the job site. How do you manage the fact that the KPIs for that customer call center of getting people off the phone quickly against the service side living in a different world, having KPIs that say, I need to not roll a truck, I need to not spend time on site, and I needed you to collect more information for me up front?
That's a really interesting one. I'm not sure how much I believe in all KPIs necessarily needing to align, and I'll elaborate on that by, I think it's good to have some professional tension. I think it's good because it creates that creativity and tension that you need between these organizations who can sometimes get quite complacent with one another, a little bit buddy with one another, and end up driving behavior completely unintentionally that wouldn't help the customer, because the customer wants to have these two things here. They don't want to spend much time on the phone, and they want to have a person there if a person needs to be there, doing the job and ready to do it. So how can you avoid that? I'm not sure this would get rid of any attention or anything, but having the customer service people be more proactive and have the data to enable that proactiveness. And I might also contradict my previous statement and say, well, actually, if the field people can be more involved in that proactive customer service, where they're getting the data straight away, saying, actually, there's going to be a problem in 2 weeks in this area, and your normal route is better being modified in this way. How about you phone this customer and say, look, I'm going to be in the area. Looks like your machine needs this issue in the future, and I can save you some pain. I can save you having to call up screaming at me. Then it's a much smarter way of working. But there needs to be, ultimately, I think, some crossover then between that customer service and the field support rep. And the skills don't necessarily mesh, but that there needs to be a newer way of bringing those things together, so the field support people and the customer service people have direct access to that more predictive data and can start to have better planning around that.
Yeah, I think that's great, but turnover in a call center is pretty quick. So making them familiar with this sort of thing is really difficult, right? And so that's the, I guess, the follow up to that is, yeah, we can try to train call centers to be able to manage and understand and process this data, right? And be fed this data in a way that helps them complete their task. But when the guy who just I spent 2 weeks training is gone a month later, there's a lot of lost effort.
Yeah, and you don't want to upskill those call center people too much because it's expensive to do and the turnover's high. So I think my simple answer to that would be change the field service people to be just much more proactive rather than getting direction from call center people. Maybe separate that work stream where the field service people are then owning that data coming in. Call center might not necessarily see it unless they need to call it up. And the field service people change their whole routine from being directed to customers to actually directing themselves based on dynamic customer needs of, okay, we're seeing these machines that we're responsible for or territories. How can we now preempt this and get ahead of it, replace that part before it fails, before the customer's on the phone to customer service, and work that way.
Right. No, thanks, David. Oh, sorry. I sort of jumped in front there. I just saw you put the message, so I didn't know if you were going to come back on. So we've got actually another question from Saeed, which is a bit more, slightly more on the technical side. I don't know if you'd like to come on and ask that, Saeed, to Alex.
Oh, yeah, thank you very much, Alex. I hope you can hear me. So I would like to ask what strategies or methods do you take up to perform some kind of a feature engineering in order to come up with a predictive maintenance system? Because the reason behind that is IoT data that I've come across to is kind of temporal signal captured against one single feature, for example, temperature or pressure or vibration, or it could be an audio signal. So if you can shed some light on it, extremely useful. Thank you.
Yeah, I'm happy to. And actually, our methodology differs from pretty much every other company that I've seen in this area. We have a library of algorithms that we've developed in-house, about 70 at the moment, that all respond in different ways, and sometimes actually these are all focused on time series data, and they are sometimes very good at certain kinds of data, like could be vibration condition indicators, and some are better with more or with less repeatable data that shows some interesting patterns or could be affected by other areas. So we actually have, and it's unusual for a company of our size, we're at 65 people. We have a full research team dedicated to coming up with new algorithms that represent the state of the art in this area. And their job is purely come up with the science that you think would be best in order to tackle this problem. And the problem is, how do you generate context out of an inherently low context environment? And to explain that, low context is we might only be getting pressure, temperature from this machine. How can we start to understand more about the actual mechanical health of that machine with this frankly quite rubbish data? And so how can we bring in other things like, what does the maintainer tell us by how they interact with the application? What do they tell us when they come in and rate something by giving it a thumbs up or a thumbs down that we've shown them? Or when they perform a work activity, what data does that relate to? And how can we start to mesh these things together so that we can understand the behavior of this machine and other similar machines with similar data sets and similar data streams coming in? So everything for us is about, how did that data respond? We develop the science to try to understand that, and we have a separate back-end engineering team who then take those algorithms and implement them in the actual code base of Senseye. We then run all of the time series data that we get against those algorithms all of the time. So every single measure, every single sensor, everything goes in, and we use a lot of processing power to do that. Our cloud computing costs are phenomenal. We then have another set of algorithms that sit on top of that and act as an arbiter to try to understand which algorithms are behaving well, which are not, how were the predictions that they came up with, and essentially doing the job of data scientists, trying to say, okay, which ones did well, which ones didn't, which ones should we assign to these machines or not, and how do we tweak that? And that's done, again, automatically. There's no way that we can bring in 3,000 machines in a new customer in under a month if we had to do that kind of work manually. And then then it shifts to learning about, okay, we've now established a fingerprint for this machine. We've now understood which algorithms are working. We've now understood how it's behaving similarly to machines in its fleet or other similar machines that we're looking at. We try to wrap in as much context as we can. And notice I haven't said anything about the machine design or what the machine actually is, or the maker or manufacturer, because we don't care. We don't think that's, again, a scalable way of tackling predictive maintenance. We have to look at the data that's available, because we've had cases where the customer says, I have one machine here, another machine here, they are identical. And we look at the data and it's not. It's either collected in a different manner, or these machines have their own rich operating histories and maintenance histories, and one's used in a different way to the other. And the result is they behave differently, they will fail differently. There are absolutely similarities that you can share amongst them, but you cannot treat these machines as exactly the same. And you have to learn what the preferences of the operator are. So think of Senseye as a Spotify or Pandora for machines. We're coming in, we're learning about preferences, we're learning about behaviors, we're learning about what the humans want. because it's our focus on humans. Senseye is not a data science tool. I've talked about lots of data science type things. It's a tool to help maintainers be more effective at what they do, be more efficient, save money. And so we don't want maintainers to be data scientists. We want to automate that, do that for them as much as possible. And so we've got to learn from them and learn what their preferences are and tweak it based on that. And again, that has to all be automated.
Right. No, thank you. Thank you for your question, Saeed. I actually wanted to talk a little bit about the human element. I know we slightly got off a little bit off topic, but I don't think that matters. Quite an interesting discussion there going into.
Well, fun to go off topic.
Exactly. And I've actually learned something as well. So I think that's really cool. But what I wanted to talk about in terms of the human element is actually when within organizations, I guess, when they start thinking about predictive maintenance and projects, they start to think about resources, how many team members, how much investment do they have to make at least at this initial stage, and as they scale up, hopefully across multiple production lines and sites. But so how do you overcome that sort of perceived lack of resources at the start, as you're just trying to show value and you maybe can't justify that initial investment, but you've got to start small. So I was just interested in that side of things, really.
Yeah, I think a key point to make is that we don't have any customers who've hired people just to drive Senseye. All of our customers use existing resources, and Senseye is not about making people's job more difficult or giving them another tool to log into. It's about making their lives easier, more efficient. Particularly if we look at the maintainers, they are super busy. They're fighting fires all the time. They're rushing from problem to problem. We don't want to give them another tool to say, hey, you guys need to go and check this, and you don't worry about that fire. No, we want to be able to actually say, okay, rather than running from fire to fire, you've got a fire coming up in 2 weeks. So don't worry about checking this thing that is probably fine anyway. Focus your efforts and your resources on this area instead. Having said all of that, particularly in the deployment phase and the design phase, there is some work needed on the customer side. And I don't want to be disingenuous and say, oh, there's no effort, no problem needed at all. You just click and you're done. I wish it was like that. But there are always organizational challenges to overcome and people that need convincing and a data storage and communication project to manage. Get the data and send it to us. And we will help as much as we can with that. But somebody on the customer side still needs to be responsible and help to drive it. It's not a lot. So typically in our proposals, we say during the initial design deploy phases, you're talking about maybe a project manager type person and an engineer technician type person for 10 hours a month, something like that. Probably spend more time in Microsoft Meetings calls at the moment, just to make sure that everyone's coordinated. Actual proper engineering work is quite low. Making sure that people are coordinated, spending time, and they are aligned, that takes a lot longer. And I think we're all generally getting used to that as we're all spending more time on Teams and things like that anyway. Actually, on that note, we've recently designed and released an extension for Teams, I think in the last week or two. So that allows people who are doing a lot of this kind of work in Microsoft Teams to interact directly with Senseye. So we're trying to give them the tools that they already use. It's integrated, the information's already there. We're not saying, hey, come and log into this other system and, oh, by the way, you forgot your login credentials. No, it's going to be there within the suite of tools that you're already used to and just make it as painless as possible. Then on a day-to-day basis, how much effort does it take? Anecdotally, some of our customers like to check what Senseye's telling them during their morning coffee. We're not talking about a lot of time. One of my customers nearby, they have one guy who logs into Senseye every morning to see what's happening. And by the way, Senseye will send an email or a text if there's something really, really important that it needs people to come and look into, or it can create work orders automatically. But to give you an anecdote, this guy, he's the main Senseye user really for an entire site. And his responsibilities are just under 5,000 machines then to be monitoring. And that takes him less than half an hour every morning to just have a quick browse through, see what's happening, And he doesn't do the maintenance on those 5,000 machines by himself. Of course, there's a massive team to support that, but he helps to direct those teams, saying, "Hey, you guys need to pay attention to this because we're showing some signs in Senseye. Let's figure out if we need to go and replace a bearing or not, and maybe do a manual oil analysis based on what we're seeing, rather than these people having to go and take random spot checks." So this is not a high time, high stress tool where you need to be constantly grinding to get value out of it. We think that's a false approach to predictive maintenance, and we don't need to be doing that either. So with customers that we've grown where they have sites more than 3,000 machines, they don't hire any extra people, and we don't hire any extra people, because if we did, we're just passing the cost somewhere else. You're just passing that cost of maintenance to human resources, or you're having to hire lots of consultants and data scientists. And again, that's not scalable. There's no way that you can monitor all the factories in an enterprise, all those machines, by taking the old school aerospace and defense approach, which is put a lot of people in a building, spend $50 million an hour, a year on that team, just in their salaries. There's that whole different argument. They have safety cases, they have assets that are worth $200 million each. Then it's worth staffing a whole building. But on your industrial site, where you want to be monitoring a drive that costs $100, you don't need to hire extra people for that. You don't need that kind of approach. Take a very highly automated approach, and that's what we deliver.
Fantastic. I think that for me, that's one of the big benefits. I know Nissan is one of our big customers. That's sort of a key part of their story, is that they didn't scale. So they didn't need to hire to scale as well. And that's the other end of the question, I guess, we talked about at the start of the project as you're onboarding, but I guess on the scale side as well, is hiring required on that side to really?
No, Nissan is actually a good example. We started with Nissan in the UK, and they had 2 people monitoring or trying to monitor all their machines. They were already collecting data. They were very mature, actually, from that data collection connectivity point. This is back in 2016. They had almost full connectivity of their machines streaming data in, and that was phenomenal already. But these 2 people were trying to analyze this data essentially by hand, and that's impossible. So what they were really focusing on were then the top 10 machines that they knew were just the problem children in that facility. And so they'd watch those and they'd get some wins. Fantastic. And what we helped them to do is then cover the entire facility, cover all of the thousands of machines you have in that factory, rather than just your top 10, and spread the wins. And now actually, they've not changed that. They've not had to hire extra people for that. They have got other people to be using the Senseye tool as well, but it's only really to show them and to help show, okay, these are the issues we've seen. Can you see this as well? And do you agree? And so you have this very collaborative way of working, rather than just trust me, I'm the data expert. No, you can share it. Everyone can see. But yeah, they've not had to hire any extra people for that. Same with Nissan North America. They're now covering, or Nissan North America. I have to change my pronunciation depending on where we are. They're now covering the 3 main factories in North America, as well as 2 in Mexico, and they've not had to hire any extra people for that. It's the maintainers themselves and the people responsible for maintaining those assets already who are the main users. And so they're not having to suddenly get experience in data science. They're not having to hire data scientists themselves. They are the people who are going to be on the front line of maintenance anyway, now have a new tool in their tool bag to help them and direct them and make sure that their effort is focused where it is most beneficial.
Fantastic. I think that's a great way to end, actually. A nice positive note to end on. Unless you've got any closing thoughts, Alex, you want people to take away from this topic?
Yeah, probably a couple of things. So again, I want to emphasize, don't get all excited about sensors. It can be very exciting, but actually consider what you have already. Because when you're doing continuous monitoring, you can take a different approach. Vibration monitoring is absolutely high quality. Generally, there's some fantastic sensors on the market that will give you, just with a single snapshot, a really good picture of what's happening on that machine, rotating machine. But actually, what if you started to look at things like your cycle time, your startup time, your shutdown time on a drive unit, that data is already available. And that will tell you a huge amount. Because you're looking at that constantly, you'll start to see minute variations. That will tell you whether your brake pad's sticking, whether your motor's wearing out, whether you've got an electrical problem, whether you've got something interfering mechanically. That will tell you a phenomenal amount, and it's free. So consider what kinds of machines you could look at, and consider what if you didn't jump to the most expensive sensing solution possible. And actually, you often don't need that, because machinery now is so competent at collecting that data itself for its own control purposes. And with new standard, well, they're not even new, with standards like OPC UA, you can query that information in a very easy to use manner, stick it in a database somewhere, and use a tool like Senseye to get even more value from that, or to generate tremendous value from that. Then it would be the culture. So that, again, technology side of things is proven. We have a lot of very good case studies with fantastic brand names around the world. So, Nissan, Tata, Unilever, fantastic customer names where it's proven, and we've shown it. So please talk to us if you want a case study about that. And in some cases, we can arrange talking to customers about that as well. And it's much better from their mouths. But consider the cultural side. Consider how can you benefit from this as a culture, and are you culturally ready? Is this purely something that isn't on an innovation level and you're going to have to fight hard, or is there actually other people who understand that, yes, there are efficiencies to be made in maintenance. Yes, there are ways that the operations can be helped by investing in this kind of technology and using it as a platform for digital acceleration. Because you want to have those people bought in and saying, yeah, okay, we recognize there's an issue, and we need the templates, we need the work to help us spread this message and spread these wins. The cultural side is right now the biggest focus point.
Fantastic. Thank you very much. And yeah, I think that we've come to the end. So yeah, we've got all of our case studies on our website. So we've got a resources hub with lots, actually more than that, actually, podcasts, webinars, lots of information, lots of more in-depth information about what we've sort of discussed today and more, really. So I'd encourage you to do that. You can obviously, if you've got any questions, please contact, I guess, marketing@senseye.io as a first port of call, or hello at senseye.io with any questions, or just contact us for our website. But besides that, thank you, Alex, and thank you everyone for participating. Hope you found it useful, and we'll see you again next time. Thank you very much.
Thank you, Niall. It's been fun, and thank you everyone for the questions. Hopefully speak to you again soon.
Click the link in the description to find out more and to be notified of our next live episode. And to see more about Senseye Predictive Maintenance, go to Siemens.com.
Thank you. Bye, everyone.
Cheers. Bye, everyone.